Hello. I'll assume you have already finished this problem. So now in the previous slide, at the end of the previous video, I asked you to try this problem, this exercise, calculate the mean weekly net profit. To do that, what you need to do here is you need to calculate the probability weighted outcomes, which is simply multiplication of the outcome, weekly net profit, and its probability, the corresponding probability. So minus 2,000 times 0.5, and 1,000 times 0.4, 4,000 times 0.08, 7,000 times 0.02. So it's easy algebra, simple algebra. And finally, sum these four numbers. If you add these four numbers, then you get minus 140, which means the average weekly net profit generated by this dealer, this car dealer, is minus $140, which means it's a loss. This dealer incurs a loss of $140 every week on average. Of course, in some weeks, the dealer is doing very well, but in other weeks, not doing very much well. And when you balance them out, the bad side, the losing side is larger. How much? By $140. So this is the simplest way to evaluate these dealers' performance. It doesn't need to be the mean, but it's the most common way to evaluate just the average performance. So, and we are now we are going to study how the transformation worked. We have transformed an original random variable, weekly sales in number of cars, into a new random variable, weekly net profit in terms of dollar amount. So it happens quite often. We would like to manipulate or transform the original random variable, typically in order to change the units. For example, when you change euros to dollars, inches to meters, like Fahrenheit to Celsius, and many other examples. And in this case, we are going to use this notation. I will use x for the original random variable, the random variable that we are given, but what we are interested in, we are not interested in x itself. We are interested in y, which is a new random variable. In our example, new random variable is the weekly sales, weekly profit, and the transformation is a function. So we assume that the new random variable is related to the original variable by the function g. So when you put x into this function, you get what you are interested. You are interested in y, which is a function of the original random variable. So in our example, this is what we have. Original variable is weekly sales and the number of cars sold, and weekly net profit is what we are interested in, which is in dollars. So you can also think it as a change of units. We are changing the units, and their relationship is simple as this. Y is $3,000 times number of cars you sell and minus the salary you took. So that's how we get the new random variable. And now then after the transformation, we are interested in the mean of the new random variable. We are interested in the mean. And the mean of the new random variable will be denoted as expected value y. That is, this is the notation for the expected value of random variable y. And because y equals to g of x, you may write it this way: expected value of a function of x. So this is why I said expectation is a general and more mathematical term compared to average and mean. So in this sense, you may think expectation itself as another kind of function. When you put x, then you get new random variable, and after that, if you put that new random variable into the expectation function, expectation operator, then you get another number, one number. So when you need to calculate the new random variable's mean, what you need to do here is you have to compute the transformed values for each outcome of y. So when you sell 0 cars, how much net profit you get, and when one car, how much you get as a net profit. And so like convert number of cars into dollars. That's what I'm saying here. And second, assign probabilities to each outcome. So think about what is the same events. And the same events have to have the same probability. That's the principle. When the transformation becomes more complicated, the probability is a little bit more complicated, but in this example, it should be simple enough. And finally, when you have the new random variable y and probability for y, then it's easy. Just then calculate the mean using method 2, right? That's how we calculate the mean of the new random variable. Then what we need to think about, what's interesting is, an interesting question is, suppose that I know, okay, I already have the original random variable, and I already calculated the mean of the original random variable. Then, using the original random variable's average, can I get any information about the new random variable's average? For example, in our example, when we already calculated that the average number of cars the dealers sold in a week was 0.62. On average, 0.62 cars the dealer sold each week. And we also know that the relationship between the profit and number of cars. So what you can do here is, you may be able to say, okay, then expected net profit is the net profit assuming you have sold this much car. Can we say that? In general, it does not hold in general. So in general, knowing the original variable's mean does not help the new random variable's mean. But in general, the answer is no. The answer to this question is no. But in this example, the answer is yes. So if you plug in 0.62 into the relationship, so replace in the relationship, in the formula, replace the number of cars with the average number of cars. Then you get exactly what you wanted. So you get minus $140, which is the expectation of the new random variable. So if you knew this formula, then you did not need to calculate the probability table for y. You do not need to calculate the weighted outcomes for y. So it could save you a lot of algebra, but you have to be careful. I don't want you to abuse this formula, because you need to correctly understand when this formula holds and when not. And the answer is, the formula holds when the x and y, the relationship is linear. The relationship between x and y is linear. Linear means y is a linear function of x, which means there are only two parameters, two constants. So when you multiply a constant to the original variable and then plus a constant to that, then you get a new random variable. Then you have this formula. Then the expected value of the new random variable is the same linear function of the mean of the original random variable, which is very nice because when you know this, then it is A and B are known. You know A and B, and then when you calculate this, then automatically you can plug this into this formula and you get the new random variable's expectation. This is very simple. And so I'm going to stop here. And in the next video, next week's videos, I will give you more examples about linear relationship, and then I am going to also give you examples of nonlinear relationship where this formula does not hold. So it's continued in the next week. So okay, have a nice weekend and see you in the next video.